again for joining our second part of today's program. So every day we had a process mining cafe where we're discussing different topics around process mining. And today I'm very honored to have a special guest along with Wil, who joins us as well. And our guest today is Manuela Veloso. Hello, Manuela.
Hi, Anne. Hi, Wil.
Hello.
Manuela, let me introduce you briefly because people have seen Wil's talk before, but they might not know you yet. So Manuela founded the Coral Research Laboratory at Carnegie Mellon University. She's a professor there. And her research includes major works on automated and autonomous robots, artificial intelligence, and machine learning. And currently, she's the head of AI research at JP Morgan Chase. So, Manuela, you have a lot of experience with AI, not just in robotics, but also the finance space now. And I'm curious, so at the beginning, I would like to ask you, can you explain to us the difference between machine learning and AI as you see it?
Yeah, thanks a lot for having me and for that question. So let me try to explain that AI is somehow a science, a young science that started in the mid 30s with Alan Turing, but then it started becoming more developed in the mid 50s. But the point of the AI science is to try to have a computer somehow exhibit all aspects of intelligence. And as such, it's a science of components, because there is the natural language part, there is the machine vision, there is the speech recognition, and then there is all the cognition part, which is all the ability to search, to plan, to actually learn, to optimize, and then the execution part, which is actually you need to have these robots, software robots or real robots, that execute what eventually the cognitive and the data processing actually generate these algorithms. So the thing is that AI has many components, and machine learning in particular is one of the components. It's a very important component because intelligence is connected with learning. But it doesn't mean that, for example, representing knowledge well, coming up with sequence of steps like this process, kind of like planning, and searching for actions or eventually optimization is not part that run without any need for learning. It's algorithms that actually perform those type of functions are also AI functions. So somehow the fact that people use the term AI and machine learning interchangeably is not correct. I mean, machine learning is a component of the large AI spectrum.
Yeah. Okay, so AI is really the much broader category we should use more appropriately probably when we talk about these complex systems that are being built everywhere, right?
Yes.
Now, a few years ago, there was I remember quite some fear of AI overtaking the world, wiping out humanity, if you will. And my sense is a little bit that this has been replaced by a more nuanced understanding of what AI can do or cannot do. What do you think about this?
Well, I think that I truly believe in the intelligence of humans. Humans are very smart, and therefore we will always be ahead of these machines, who knows. And so I don't fear, in fact, AI taking over humanity, but I actually fear the opposite, is that people are not focused on these hybrid intelligence, which is what Wil was mentioning, which is accepting that there will be this AI in par with the humans. So one day in the future, there will be hopefully humans and cats, dogs, but also intelligent machines. It's not about assuming that we are going to be the only intelligent creatures on Earth, in the universe, but there will be these other creatures. So the science here and the engineering and the study needs to be, how do these things interact? And the same way that there are bad humans, there might be bad AI and biased AI. But I mean, aren't there so many humans that are also not really that good? So I'm just saying. So for example, in my new kind of head, in the financial world, there is so much financial crime. I mean, literally, like money laundering, fraud, you name it. That I tell you, it's not an AI system doing any of those things. I guarantee to you that it's not. It's people. So I think that AI needs to be seen as okay, you can be afraid of AI if you train the AI system only on bad data, and decisions can be a function of that data. But if we are careful, and if we care about like AI for social good, AI that is ethically correct, we can have the machines even help the humans to be better for humanity. I really believe that we are going to have less biases systems, AI systems, than we have the chance of having biases people,
Yeah. Yeah, so I hear you saying we're maybe even a little bit too conservative in a way to accept and reluctant to accept the AI into our lives. What do you think, Will?
Okay, Will. Go ahead.
Sorry.
So, like as I explained in my talk, I think that the interplay between humans and machine will be something very interesting. What is for me interesting to see is so we have 4 children and we have a house filled with Siris and Alexas and the whole bunch of it. And at the same time, you see how young children accept these things as somehow intelligent objects. At the same time, we also realize how stupid they are. So in our family, we will have these own internal jokes that only we understand, and that no robot will ever understand. So I think that's very interesting. Perhaps, if I may, I would also like to comment on Manuela's initial statement on AI. I have a bit of a problem with how we define things, right? And let me try to explain what I mean. And so some people that hear about process mining and see it for the first time, they think there's mining in the name. Process mining is a specific type of data mining. And then there are the machine learning people, and they would say, well, data mining is just a form of machine learning, right? And then there are the AI people, typically in different camps, but they would say, well, machine learning is part of AI. And I don't know, I favor myself, the term data science, because I was responsible in Eindhoven for the Data Science Institute. And I said, well, AI is just a subset of data science, right? The difficulties of these definitions is that people, I think, continuously interpret terms in a broad or narrow sense, whenever it fits them, right? And so I'm one of the leading persons in the AI center here at RWTH Aachen University. It's a big university. There are 75 groups involved in this AI center. And of course, this is interpreting AI in a very broad sense, and ranging from vision to people working in mechanical engineering and trying to optimize certain production processes, etc., etc. But there are also people that say, well, there are the 75 groups in the AI center, but there is only one group really working on AI.
Yeah.
Could you comment a bit about the danger of using these terms also when they appear in the newspapers, that they can mean completely different things?
Oh, I believe that indeed the terms used are completely misused or used with different interpretations. For me, Will, I mean, AI is not part of data science. Data science is part of AI. So
I was trying to provoke you.
No, it's because, I think that we have to understand something. Data science is like some science to analyze data. But AI is everything. AI is like being able to understand language, being able to have a robot move around, being able to make decisions about which action to take to achieve a goal. It's these these overwhelming capabilities that humans have, even like negotiating, dialoguing, you name it. So AI doesn't fit any concept except the most general concept of having machines be intelligent as humans. So, and now we can be creative as much as we want, but it's not a data science issue because we are intelligent ourselves because someone taught us. And I'm going to be here also provoking you, Will, because it's like this. Think about machine learning or this obsession we have with data now, okay? Which is interesting. But think about this. I was looking the other day, and do we see any parent walking on the street with their kids and be pointing at everything? This is a car. This is a table. This is a person. This is a bike. This is what? Do we see anyone interacting with their children? Okay, this is a spoon. This is a cell phone. This is a. Where are we in this labeling thing? We interact with intelligent creatures, and we are not labeling mode. I mean, I tell you, I have grandkids, I have had children, and I was never like thinking, oh, today I'm going to give examples of spoons. Let's bring all the spoons and say, this is a spoon, this is a spoon, this is a spoon. It's ridiculous. The way that we think that intelligence needs that amounts of data. Now, what I did with my kids, and I'm sure you did this with other intelligent creatures, is like this. Okay, eat your soup with a spoon. That's it. You are done. Okay, pick up like the meat with your fork. You are done. Somehow, this connection between use and concept gets it absorbed by the brain. I never had to tell my kids, okay, yeah, I told you to use the spoon. That's not the spoon. That's like a fork. And here is another fork. And here is another knife. So I really think that data is very useful eventually to capture behavior. Examples of games of chess are very useful to capture strategy. Or other things, I mean, examples of how people talk with customers on the phone are good examples of how the processes are done. But there is a lot of like things that, it's not about data. It's about really having a way to have these machines understand what we say. So I don't think this has nothing to do with data science, has nothing to do with machine learning, but it has this other dimension that we may have embraced or not. But this understanding concept is quite complex. And I see AI as this combination of everything, understanding, using the data as examples, being able to ask for help. What do you mean by that? So this is like how we are going to build these AI systems that are so flexible in terms of being intelligent. That's what I'm thinking. So, Will. I think you agree with me, Will, in one way or another.
Well, but it depends a bit on how you, like how one uses it. So you give, I think, a very precise, valid definition of AI, but by that, in a way, you're also making it smaller than how it is typically used in normal language, right? By scoping it like that, I think I can, for me, it is very difficult to imagine with your definition that we would currently have an AI bachelor, for example.
An AI what?
An AI bachelor program, right? Like a data science program, I can somehow see in front of me. But with your definition, the question is, do we know already enough? Is it broad enough?
Maybe let me jump in here, because I do think the definition question is very interesting, but let's not spend all of the time on it, because I'm very interested what we were talking before. And Manuela, I was cutting you off when you were saying basically maybe I was asking you, are we a little bit too conservative accepting AI into our lives and having this kind of hybrid modes? And I know that, for example, Wil, you have been very active in especially also the aspects of responsible data science to define work on algorithms that are fair, transparent, and having these kind of ethical things, right? And Manuela, you were pushing back a little bit against that. So maybe let me ask you again, do you think we are a little bit too conservative as humans in accepting?
I'm not sure exactly what does it mean to be too conservative. I do think that people have to jump more into opportunities of using AI in their jobs, using AI to assist them. I mean, I think people are not moving as fast as probably I think we should. And I don't know. I just think that there is a lot of, thank goodness there are all these tech companies that develop like open tables and ways and you name it, all those tools that are very much like, or recommendation systems that, they exist to help you in our daily lives. I think that we should all, in companies in particular, think about processes, think about like data, think about interactions, think about like goals, outcomes, and just think AI, just think that. So I give you a very concrete example in which I think that people have not, you guys are on this process thinking forever, have a lot of experience, but many people do not think about their processes in a very disciplined way. It's almost as if everybody's cooking and nobody writes recipes, so they just cook, but they are incapable of saying, these are the ingredients, these are the quantities, these are the steps. And that's what I think. Thinking AI, people are not, disciplining their thinking to be able to assume that the machine can help with this. So that's what I for one reason or another, one way or another, I think that the concerns about explainability, fairness, and ethical systems are great, but we have to move on in building AI in our lives much more. That's what I'm saying. Otherwise, we are being so stopped by those needs that we just don't advance as much as we could. That's what I'm saying.
Yeah.
Yeah.
Yes. So maybe, do you have an example of AI? So from the finance space, robotics also perhaps. So
yeah, very nice. So let me give you an example. So like Anne said, I've been working for 30 years at Carnegie Mellon, and my passion has been on trying to combine these data, the planning, the perception, the cognition, and action. And one of the frameworks is actually mobile robots. So robots that move around. So they have to capture all the images. They have to capture all that people tell them, and eventually select, do I go left, do I go right, if I'm going to Manuela's office, and actually go. So these integration of perception, cognition, and action has been a lot of the work that I've done at Carnegie Mellon with my students on these automating this process. And we have had robots that have moved at Carnegie Mellon, many thousands, more than 1,000 kilometers. And Joydeep Biswas and other students of mine, Brian and Stephanie Rosenthal, have been like pushing this forward. But let me tell you, at JP Morgan, there are many things also of the same nature. So we talked about robot software. There are chatbots, of course. But what I think it's very important for us to understand is also that AI is about, when developed, is about levels of automation. So it's like the autonomous cars that you have level 0 up the way to level 5. So in AI, it's also at JP Morgan, the examples are also of that nature. Some are still very rudimentary, level 1. So maybe a chatbot that does nothing but only gives like canned answers to the person, all the way to having a very smart chatbot that is able to understand, learn, interact, propose things, and actually execute them. I don't know if we have many of those. We have many of level 1, level 2, kind of like AI chatbots. And for example, one thing that we have done at JP Morgan within my group is, for example, and this is, I think, very interesting, is automatic document generation. So you have to understand that all this data is saved as Excel files, or it's saved as text or conversations as speech to text. But then it needs thousands per second. JP Morgan is gigantic, and 100 million customers, in retail. So it's all these very large data coming continuously. And then sometimes you need to know what's going on. And then these analysis is people do it by looking at Excel files or mining information, a lot of it manually to assess what's happening. Of course, there are dashboards and tableaus, but now we built a complete DocuBot, which is a bot, an algorithm that generates documents. So the human can say, I would like to analyze this data. So it translates speech, requests in speech, or in text, or in language, to actions that these DocuBot algorithm can do. And literally, we can generate decks of slides, sets of slides, all automatically by transforming the language requests plus the data into a new representation. What I like about this example, which we have done for PowerPoint and for Word, is that it's looking at this problem of analyzing data as a translation problem. So it's not French to English, or German to Italian, or Portuguese to Chinese, but it's this thing about whatever internal representation these machines have, like these computers have, Excel or whatever other representation, some SQL, doesn't matter, to a representation that is meaningful for humans. So we write actually text, we generate sentences, we generate insights about the data automatically, finding drivers, what went up, what went down. All sorts of different skills that this DocuBot has. And beautifully, it doesn't move in corridors like at Carnegie Mellon's My Robots do, but it generates automatically hundreds of pages of reports and analysis of data in a language that humans can understand, be it PowerPoint slides, be it Word documents, be it well-formatted, kind of like other reports. So I'm fascinated by this problem of actually using AI to now be this translator. And it's not language, but it's still a translation problem. So that's one aspect that we have done at JP Morgan. And other issues related to fraud detection have been very deeply, and I explained to you also this fraud detection very briefly, which is this concept of actually, discovering behavior. So it's not a classification based on a single transaction, but now you need to build this network. And so this person did this to that, this happened, whatever, and then you find these pattern of interaction between a specific customer and whatever this customer is transactions of that customer. And interestingly, AI is able to detect that those type of interactions or that type of behavior out of millions. There are we get like 90 billion records of payments of transactions easily in a month. So it's not a human, you cannot do it yourself. You have to have these computers, and then you can choose to have some rules deciding what's bad behavior, or you can use more AI sophisticated techniques to actually analyze all this data and find like exceptions to graph-based behavior. So this is a very interesting kind of like two examples, the DocuBot example, this fraud detection by doing like graph-based analysis of a lot of data. These are two examples of AI kind of like systems or AI tools that we have done.
Yeah. Sometimes when people mention like something like fraud detection and they ask whether this is something that you can do with process mining, I usually tell them that this is more of an AI thing, right? Well, would you agree, or has there been some research recently where also process mining has looked at those types of problems?
Well, of course, if you look at detecting unusual behavior, you could formulate that as a process mining problem. Of course, process mining is more focused on end-to-end processes that are that is what it is intended for. But to come back to your original question, Anne, that is, so I think as many people know, I have been very active in the field of what we call responsible data science to think of things. There we looked at things like fairness, confidentiality, and these types of things. And I think some of these problems are great research problems because governments are forcing us to work in a particular way. And this is generating interesting scientific problems. At the same time, and I think Manuela would be astonished if she would live in Germany, what she would be confronted with. I think some of the things have gone. Sorry?
Why? What aspect of Germany with what?
Well, if you look at GDPR, the GDPR interpretation, like the rules that were created and how they are interpreted in Germany.
I see.
It is absurd. I brought my car was serviced a few days ago, and I have to fill out multiple declarations that I'm okay with the use of my data for the garage, for Porsche as an organization. So I had to fill out three Datenschutz agreements just to have my car serviced. And I think this has become absurd. And I think in many cases it is used as an excuse to not do certain things. Also, if I see how Corona is being handled and all the data problems that are there, I think many of the things where we are trying to protect individuals, we are actually harming them. And people, it sounds perhaps very dramatic, but people are dying because of data protection regulations. What I like, if we talk about this use of AI, etc., one of the things that I think is more important to discuss are the economic effects of certain platforms, right? So we talk about data protection in a world where we accept that, 95% of our search messages are done via Google. 90% of our online shopping is done through Amazon. In all of these discussions, it very quickly goes into the privacy, being afraid of intelligent technology. I often miss this economic perspective. That it's, as you said before, you're very happy that the tech companies are driving that, but at the same time, the tech companies have monopolies in all kinds of areas where the government should do something in an economic sense, not in a privacy sense.
I see. Yeah.
Maybe one thing that I'm curious here in relation to this is that this whole area of responsible data science, it has different dimensions, right? And one of the dimensions is transparency, and isn't creating more transparency about these kind of black box models also a way to actually increase acceptance and to maybe make people a little bit less conservative and more accepting of that? And Manuela, I know that we talked before briefly about something that was a little bit of new for me. It's called explainability research, right? Can you maybe explain what it is and give some examples?
So this is a very good question. So So think about a computer, an AI, how do you say, example-driven, trained AI algorithm that decides you can have a loan, you cannot have a loan. You can have a credit card, you cannot have a credit card. So it's like a machine that is able to use data and learn data, supervised data that said, oh, these people gave loans to these customers and not to this, and eventually learned to separate these loan, no loan kind of like decision. Now, if someone asks this machine, why did I not get a loan? You kind of expect an answer to this why question. In fact, humans, one of the aspects, the most prevalent aspects of intelligence is the curiosity that people have. So there is a need to understand that we cannot interact with things that are incapable of answering a why question. Why am I alone? Or why are you saying this is a cat and not a dog? Or why am I supposed to do this if you give me a list of things I'm supposed to do? So think about interacting with a human that would never be able to answer a why question. That would be weird, and you would think, I mean, what type of human is this, right? So now, when you think about writing now code or writing an algorithm that is trained with data, explainability, XAI, explainability of AI, is to try to include in the algorithm or in the process a way to answer these why questions. So we have done several approaches, and I have to explain just one final thing. So there are approaches that are local, which means this specific instance, why was it a loan, no loan decision, or this specific image, why is it a cat or not cat? So it's not about the process in general, but it's about this specific thing. And that's called a local explanation. And the other problem is that if you would like to look at your code and decide in general if this code is why, how does it make decisions in general, not in this specific example, that's called a global explainability. So the machine should be able to explain the algorithm that it uses, either by giving examples of loans and no loans or not. So these are difficult problems. So when this AI system is, for example, a neural net, it may be hard to trace back a decision of loan, no loan to an adjustment of parameters given data. So these neural net is given the data, adjusting parameters and converge to learn separators, but it might be hard to actually explain this. So the way that we look at these many times is, and there are techniques to do this, is to actually try to find which features of the data were important in terms of like making a decision one way or another. So this is a feature importance explanation. So they want to say, oh, because, your income was too low, or because you don't have a credit card, or so you try to find features, not out of the process of the decision, but features of the input that make the separation between classes. So that's feature importance explanations. But there are other types of explanations that we have been generating also that would probably also explain what an AI system does. So, for example, coming back to the planning and process planning kind of way. Suppose that, so let's just think about policies. Policies are functions that tell which action to take out of a particular state. So there are reinforcement learning, for example, learns a policy. And now you might want to say, why am I ask this reinforcement learning, why am I supposed to take this action on this state? Why am I supposed to do this? And so the machine just tells you do this. And so now if you think about this gigantic policy, a global explanation could be extracting from that policy kind of explanation of the sort. If the state includes a red object, the action is always to do something. So now you convert that function S to A into finding similarities between the states and the actions. So you spell out that these always happens. I always choose this action when these features are true in the state. So now you are trying to transform a function, which is very kind of opaque, S to A, into this kind of like model that explains the function itself. So there are many techniques, but what I want us to understand is that I think in steady state, in the future, it's not going to be possible to be interacting with a intelligent algorithm or an algorithm that claims that it's intelligent, that it learns, that it's capable of dialoguing, that it's capable of thinking, and so forth, without injecting into that also the ability to answer a question, why? Why are you telling this? So AI needs to embrace this why question into the algorithms also. And so that's why this field is difficult, because you now want to extract eventually from techniques of search an explanation, but it's inevitable that we have to, in fact, augment AI algorithms to be also generators of explanations one way or another. Whether people ask or not, you need to be able to trace things to generate such explanations or examples or all sorts of different types of algorithms. And it's at JP Morgan, we created a center for explainable AI just to investigate how to make this happen. Now, the financial domain, just to finish, is a particular one where if we use AI for decisions, also we have it's a domain very regulated. So either it's the customer that can ask you, why did I not get a credit card? Or it's the government that can ask, why didn't you actually made a loan to this company? Or why did you choose to trade these at this pricing? So the level of detail of the why questions of regulators or customers is very challenging. So within the financial domain in particular, we need to equip all these AI systems with non-biased decisions, explainable decisions, fair decisions. So that's a big area of research and development within our domain of finance, AI in finance. The robots, in fact, this all started also at CMU with the robots. In fact, when these cobot robots were moving around, I had this all started with also me asking, why are you late? So I would expect the robot to arrive at 3 p.m. and it arrived at 3:10. And I'm like saying, what in the world? I mean, you are supposed to be here at 3 to guide my visitor back to the elevator, and you arrive at 3:10. And this machine, eventually, this is a thesis of one of my students, was able to compare the time it took traversing the environment with the expected time by the planner, and say, well, you know what, you estimated this was going to take me that long, but actually took me more because there was too many people around the kitchen area or something, and I had to navigate. So there was a need also to have explanations with the robots because they were just doing their own stuff. So I actually, to tell you frankly, this is one of the areas that I find more fascinating currently. I mean, of course, the safety, like Wil was mentioning, is a very beautiful area. But thinking about being able to have our algorithms explain, and in fact, with different levels of detail, how they actually perform their actions I think it's very important.
Yeah. Very, very interesting. Thank you for sharing these. We're nearing the end of the session, but Wil, do you want to have some last words on this topic as well?
Yeah, so I think the area of explainable AI, and I completely agree, I think is very, very interesting. We just started a new project together with the University in Bielefeld with Barbara Hammer, where we are trying to apply explainable AI in process-related settings. So I think that's very important. I think also there is like if I relate it a bit to process mining software, I think in the future, if we see a bottleneck or if we see deviations, we want the process mining software to tell us why that deviation is there. And I think so perhaps based on a neural network, we can predict whether something is going to deviate or something is going to be late. But that doesn't help you if you want to change the process. If you want to change the process, you need to be able to generate an explanation why something is late or deviating, because that gives you the opportunity to perhaps change things.
Yeah, exactly. Well, that's, I think, the perfect place to end. I think we covered very interesting set of topics here in this last Post-Mining Café. I'm very happy that both of you could make the time and joined us here today. You gave very interesting perspectives and a lot of things to think about. So thanks a lot, Manuela. Thank you, Wil, for joining us here.
Thank you for having us.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Okay,
I'll let you go now. Thanks. Bye-bye.